7.5, solving quadratic equations by factoring now. So in this section, we want to use our graphing calculator as little as possible, potentially not at all. We want to use our skills of factoring to solve for when our x values would equal 0, so we can determine where our x-intercepts would be that way instead of graphing it on our calculator and calculating those intersection points as well. Example 1 says solve the following quadratic equations. A is x squared minus x minus 6 equals 0. So the first thing we want to do is factor that. So we're looking at our a times our c, what multiplies to negative 6 and adds to negative 1. We don't have a value out front of our x squared besides a 1, so we can just use our two brackets. Two values that would multiply to negative 6 and add to negative 1 would be negative 3 and positive 2. So x minus 3 and x plus 2. If I added those, I'd get negative 1. If I multiplied them, I'd get negative 6. Now, if it equals 0, this first term needs to equal 0, and or the second term needs to be 0. So if x minus 3 equals 0, then x must equal 3 in that bracket. If x plus 2 equals 0, then x must equal negative 2 to make that bracket 0. Those are our two solutions. X equals 3 and x equals negative 2. B, we want our equation to equal 0. So we want to subtract 5 from both sides to move it all over to the same side. Subtract 7x, subtract 5 equals 0. Now we need to factor. My a value is a 6, it's not a 1, so I'm going to use decomposition. Still a times c, so what multiplies to negative 30 and adds to negative 7. Factors of 30 would be 1 and 30, 10 and 3, 6 and 5. So 10 and 3 would work for 7. So 6x squared, subtract 10x, plus 3x minus 5. Factor the first two terms and the last two terms. So in this first one, I can factor out a 2x, and I'm left with 3x minus 5. The second bracket, I need it to be 3x minus 5, which it already is, so let's factor out just a 1, which won't change it. My factors there then are 3x minus 5 and 2x plus 1. So my solutions, again, are what would make those factors 0. From our last video, I talked about if you have a value in front of your x inside your brackets, it's opposite sign of whatever you have in there, so that's a negative, so I'm going to have a positive. Constant over coefficient. Positive 5 over 3. In this bracket, opposite sign, so a negative, constant over coefficient. Negative 1/2. My two x values would be 5 over 3 and negative 1 over 2. C. We already have everything on one side with the right-hand side equaling 0, so I can first look for a GCF. I can factor out a 2x, and I'm left with x plus 3. So what would x need to be in both these terms in order to make that equation equal to 0? In the first term, if I multiplied 2 by 0, I would get 0, so x would equal 0. And what would I add on to 3 to give me a 0 would be negative 3. D is already factored for us, except our right-hand side is a 2, not a 0, so we need to subtract 2 from both sides. But now it no longer looks factored. So let's distribute this back in so we can include that negative 2 in our factoring. So we'd have 3x squared plus x minus 2 equals 0. So we're trying to identify what would multiply to negative 6 and add to positive 1. So if I added 3 and negative 2, I'd get positive 1. If I multiplied 3 and negative 2, I'd get negative 6. So plus 3x minus 2x, factor the first two terms and the last two terms. Could factor out a 3x, and I'll have x plus 1. Factoring out a negative 2, and I'll have x plus 1. X plus 1 is our common factor there, and 3x minus 2 is our second factor. What do I need to add on to 1 to get 0? X would be negative 1. What do I need to add on? Multiply onto 3 and subtract 2. So when I have those terms like that, again, it's opposite sign. Constant over coefficient. Positive 2 over 3. So everything we circled or boxed is our x-intercepts, our solutions, our roots for all of these quadratics without having to graph them. We can solve algebraically now through factoring. Example 2. It says a rectangular garden has dimensions 5 meters by 7 meters. When both dimensions are increased by the same length, the area of the garden increases by 45 square meters. Determine the dimensions of the larger garden. So figuring out what am I adding on if it's going to be the same. So let's look at what it is right now. Right now, area equals 5 times 7, length times width. So the area would be 35 meters squared. That's what it is right now. But I'm going to be adding something onto each dimension, but it's going to be exactly the same. So my area, let's say new, I'll put a little n here. The new area will be 5 plus something, and our something is going to be our x value, that new added on length, and I'm going to add that same thing onto my length of 7. But what I also know on the left-hand side is that what my area was 35 meters squared, and I'm adding on, it's increased by 45. So I know I'm going to have a 45 square meter increase on that side. So I can rewrite my equation like this. I know my area is going to be 80 square meters, and I can represent my length times width like this. In order for me to solve for what those x's are, though, I need one side to be equal 0. So we need to subtract our 80 to the other side and FOIL out our 5 plus x times 7 plus x so that we can refactor that with the negative 80 in there. So 5 times 7 is 35, plus 5x, plus 7x, plus x squared, subtract 80. So reordering that, so we're a little bit more familiar and doing some simplifying, I'll have x squared first, then 5x plus 7x is 12x. 35 subtract 80 is negative 45. So we want to factor this. What would multiply to negative 45 and add to 12? So factors of 45 are 1 and 45, 9 and 5, or 15 and 3. I can think of off the top of my head. And 15 and 3 would work for 12. So we need a positive 12, so I'll have a positive 15, but a negative 3. So that when I add those, I'll get 12, but when I multiply them, I get negative 45. So what are our solutions? Well, in order to make this first term 0, x must equal negative 15. And in order for this term to equal 0, x must equal 3. So you have two possible solutions, but not necessarily both are correct. They satisfy our math here, they satisfy algebraically, but not necessarily in terms of the question. So we're asking what length are we adding on to those dimensions for an increase. I cannot add on a negative 15 meters to make a larger object. I also can't add on negative length as well. If I did, 5 plus negative 15 would leave me with a negative 10 meters, and that's not a thing in measurement. We can't have negative length. So our actual answer is the x equals 3. So the question says determine the dimensions of this larger garden. So once we know that we're adding 3 on, what would those dimensions be? Let's go plug that back in. So into these two. So 5 plus 3 and 7 plus 3 would be 8 and 10. And that needed to equal 80 from before, 35 plus 45. And 8 times 10 is 80, equals 80, so we know, therefore, we are correct. So our new dimensions are 8 meters by 10 meters. Example 3. A football is kicked vertically. The approximate height of the football, h in meters, after t seconds is modeled by the formula h equals 1 plus 20t subtract 5t squared. You might recognize this question before. We've done it already in this unit, but we solved it graphically, and I want us to go through how can we factor this and identify some of our answers that way. So the first question, determine the height of the football after 2 seconds. So again, 2 seconds, our t represents our time in seconds. So we just need to plug in 2 wherever we see a t here. So what's our height? If we have 1 plus 20 times there's a t, so 2. Subtract 5 times 2 squared. So what's our height? 1 plus 40. 2 squared is 4. Times 5 is subtract 20. 41 subtract 20 is 21 meters. So that had nothing to do with factoring yet. That's just solving our question using our equation and using algebraically instead of actually identifying those points on our graphing calculator. Part B, when is the football 16 meters high? So at what time is our height 16? So that's 16 equals, our h is now 16, 1 plus 20t, subtract 5t squared. So we subtract 16. We know before we factor we need to have one side equal to 0. 1 minus 16 is a negative 15 plus 20t, subtract 5t squared. So for me, because I like to see my variable squared first, I'm going to rewrite that in a negative 5t squared. Then my 20t comes, and then my constant. Our first step in factoring is always check for a GCF. I prefer having a positive 1 for my t squared, so I can divide everything by negative 5. And I'll have t squared subtract 4t plus 3. That makes an easier quadratic to factor. So I'm running out of room, I'll just move that up here. So 0 equals negative 5 is going to stay. Now what would multiply to 3 and add to negative 4? So x minus 3 and x minus 1. So my factors here, nothing can happen to my negative 5 to make it 0. But as long as those two factors are 0, multiplying onto my negative 5 will still make my function 0. So in order to make x minus 3 0, x would have to equal 3. And in order to make x minus 1 0, x would have to equal positive 1. Again, our x's, or our t's in this case, are in terms of time. So you should keep your variables the same and when you answer. So I'll say t is 3, t is 1, and this is seconds. So when is the football 16 meters high? Well, the football is 16 meters at 3 seconds and at 1 second.